Hello everyone, video 2 of module 5. In this video we go through finding the errors and refining the model and do troubleshooting. So we've done the basic analysis without doing any fine-tuning on the structure, and we had some intentional mistakes. So now let's see what's happened if we have those mistakes and we don't fix it up. The best way you can see the result either using displacement for any kind of load or modal analysis. But before going through this, we can always go to the folder that we saved the file and the output, and there is a file here named the same as the name as the model, but it's a text document, and the sign is like a text, so you can find the icon easily. If you click here, you can see the summary of the analysis. That's the summary that we saw at the end of analysis, but it's saved here. SAP doesn't give you a specific address about the location of the errors, which element have error or what's the cause. It just very generally gives you some information about the integrity and P delta, or if the analysis it doesn't converge. When you go down, you can see here modal analysis is very sensitive. So if you have any kind of abnormal period like this, which is quite high, actually all of them are quite high, that shows that there are some elements that are not integrated with the structure properly, or any mistake in our modeling. We need to find them out. So let's back to the model and see how we can trace them. I'm using my 3D model and I'm coming to deform shape, and I'm using modal analysis. There are two options here. You can use automatic scaling or you can use user defined. For modal analysis, I suggest keep automatic scaling because SAP automatically scale it up based on the actual movement that the structure has to make it more visible. And then you can just press apply, and you can see here the period is very high. If you start animation, you should be able to see. Sometimes it's hard to see because the structure is very complicated. If you pay attention, you can see something is moving here. Those are the columns we had that we didn't actually mesh the shell or slabs connected to those columns. We have the same story probably for the wall here. So let's move on. If you press here, this is currently mode 1. If you come here and press this, you will move to mode 2. So if I start animation here again, if you pay attention, you can see this wall is moving here. It's not very clear. How we can make it more clear? We have few options. If I get back to set display option, generally what I do is I'm coming and choose not in view for frame and areas, but keep the joints visible. So when I apply these, all I have is just joints. So now if I start animation, I can see which joints are moving. So how can I figure out and click on them? Here, when you come to displacement deform shape, there is an option here, wire shadow. If you disable this one, you have just the joints, and if you start animation, joints are moving and you cannot figure out exact location sometimes. But if you use wire shadows and apply, you can see here the gray joints. So if I zoom in a little bit in this area, I can see those gray joints. The rest of joints are exactly matched because this is currently the major move. If you go to other modes or other displacement that all joints are moving, you can see all grays and black joints together. So when we moving this, you see the alignment of the joints. So these three gray ones are actually these three that are moving. So if I stop animation, I need to go to undeformed shape, I just need to bear in mind where they are, and then I can select those joints, and then I can find them, where are they exactly, and how I can fix them up. We know where they are, but this is the way that you can find it. If you use modal analysis, this is one way that you can find the errors, and the other way is using displacement of other load cases or load combinations. For example, if I go to CombU G2 and press apply here, I can see unstable elements that are moving, not just one dominant element that is the result of this modal analysis. So modal analysis doesn't show you all instabilities. Modal analysis show you them one by one, and if one element is very unstable, you may have few modes just for that specific element. But when you go for using loads, then you can easily see how many elements are unstable. So you can see bunch of elements are moving here, so it's not just one. So what I can do, I can back to set display option, and in set display option I can, for example, keep areas not in view but put frame in view and apply, just to make it a bit more clear. I know roughly when it's happening, so I'm zooming in for this area to see where they are. Again, I know where they are. Those are the beams that are not connected to the wall properly, and you can see those beams are moving here. So if I stop animation and bring areas actually in the view, and now you can see that this is the side of the core wall that we didn't do any meshing, we didn't add any beam. The rest are stable, but this area not. So we need to fix those. So currently these two, also we had that wall that we put here. This wall is not stable as well, but is not as critical as the others. So that level of displacement doesn't show you this wall is moving, but you saw it in modal. So the combination of modal and displacement of different loads can give you an idea which element needs to be fixed. Okay, let's back to the model and see what we need to do and some other fine-tunings that I will show you to minimize the errors. Okay, let's make this full 3D. And the other thing you need to pay attention is when you have such a joint and you have, for example, movement or modal anything, you don't see any movement in those joints, because what SAP does is SAP automatically restrain all those nodes, so you cannot track them and find them. What you can do to get rid of those nodes, so let's unlock the model and I'll show you what you need to do. To finding all extra nodes, if I press Ctrl A, you can see I have 10 points. And then if I come and merge those joints, for example for 20 millimeter, and apply, still it doesn't go because it's not close to anything. How we can get rid of those extra joints? We can come here and put not in view, and then apply, and then I select all my joints 15, 10. Then I press delete. Have a look at this. It's gone. And we have another one here at the middle next to the column. That one is gone as well. So if I press Ctrl A again, I have 1508 points. So 2 extra points I had, they're gone. So I will put this one back. Just one thing I need to tell you about using this not in view and invisible. We have not in view for all joints and frame and areas, but we have invisible for joints as well. When you put not in view and apply, you don't see any joints. Yeah, but if you put invisible, so if let me back to this, if I put invisible and apply again, I don't see the joints. What's the difference? Here is just invisible, but you can select the joint. So if I come here and select this area, you can see the points are selected as well. So I have selected 6 points and 18 frames. Yep. So if I press escape and remove invisible but put not in view and apply, then if I select, I don't select any points. So that's the difference between not in view and invisible. If you don't want to see any element, if you don't want to select any element for your edit, you need to use not in view. If you just don't want to not have it in the view for clarity, you can use invisible, but you are able to choose them. Let's move on. So we remove our extra joints. Now what we need to do for the rest of element. Let's start from lower level. So this is Z0. So here I have a wall here and I have a column here. For auto meshing, generally I prefer not to have just 2 endpoints for a wall. Better to subdivide your wall in actually more elements. How we can find it? This wall is just here, so it's not very easy to find it, but what we can do to see the wall is I can come to set limit view. So I'm coming here in set limits, and here I can choose between Z0 to Z4 is the area that I have this wall, and apply, and then I see this wall easy. So what I can do, I need to deselect the slabs. So I'm selecting those group, then I'm coming here to select, I go for deselect, property, area section, and I deselect 200 slab. If you realize that either select or deselect, you have both options here. So actually you can go for either of them. Now I'm deselecting the top slab. If I press show selection only, then I just can see the walls. So now it's easier for me to come here and fix this one. I will zoom in just to show you what else we can do for fixing the wall. I'm replicating this wall to another bay to show you what else can be done. So I am coming here to replicate elements, and then I just move this one, for example 12 meters farther. So I put here dx12 and I want to keep it, so I move it here as well. You can see one coming here as well. So I have 2 walls. I'm doing intentionally because I want to show you different way of connecting this wall to the slab. So as I said, my suggestion is don't have just 2 points at the end of the wall, because it doesn't give you enough integrity properly to transfer loads to the slab. Better to make it a little bit in smaller sizes, just vertical, like what we did for the core wall. So it's roughly about 4 meters. I prefer at least 3 segments for a section. If it's a very small segment, that's fine, keep it as it is. You may have just 1 meter blade column, leave it there, that's okay. But if it's a 4 or 3 meters wall, better to subdivide it. So I'm selecting these 2, then I'm coming here and using this divide, 1 to 2 I will put 3, and 1 to 3 I will put just 1 and apply. Now I have a better connection here to the slab. Now let's see how we can connect these shells and columns to the slab better. I am selecting this column and this slab, and also this wall and this slab, and I'm using subdividing. So for divide selected area, we discussed about this before, so I'm not going through the details, but we need to see what options are available for us to use it here. So we can use divide area using cookie cut based on selected point object. That gives you the degree. I told you it's 0 or 90. SAP actually created in both directions. Or you can come here and say I want to use maximum size of divided object, for example 4 meters. This one gives you more elements here. So I'm trying this. Even if you put maximum size 4 meters and make it very flexible, if I press apply, you can see there are lots of joints here. So this is okay, but for this one is too many. Just you need to be very mindful about the number of joints and elements you're creating. Even when you're using automatic mesh, yes, it's not actual joints, but they are dummy joints. And those dummy joints, even if they are not matched, if they are not connected, they shows instability. So ETABS is more advanced in terms of automation comparing to SAP, but we need to just find a good way to deal with SAP. So I press here Ctrl Z to remove what I've done. I will back to this because this is under my control. So I'm selecting these elements again, these points, and selecting this one, and I'm coming to this option. And then I put 0 degree, doesn't matter. When I press apply, you see I just have shell as much as I need, not too many. So what I will do with this one here, I will select those and I will select this. I'm just using assign area and auto mesh. I'm just showing you guys the different ways of doing this, just to see the options available for you. So you see those are pretty similar in terms of the menu, and you have the same access. So if I come here again, the same auto mesh area using cookie cut based on selected point object, which is quite similar to this, and I put 0 degree and then apply. I see here is just mentioned cookie cut. I don't see the mesh at the moment, but they are there. So I go to the next level. I'm doing again the same for this. I'm selecting, I'm using cookie cut, so I apply this for automatic area mesh, apply, and then I'm coming to here, select those, and going to this menu and using this again and apply. So here, because this is physically subdividing this shell, you can see everything, but here you just can see a sign. The rest is no, that means nothing has been done for them. Let's move on and fix the rest. I need to, okay, I think I need to press all to be able to see the rest, or I change my set view limit. So I need to come here, show all, apply, then I have them all. So let's move on and see what else we have. So we've done this level, we've done this level, and now we are here and we have another joint here. For this joint, I'm going for auto mesh option, and I'm choosing this one. Just give me, when you are not clear that what will happen, you can try that a specific auto mesh option with dividing selected element, and when you figure out exactly what's happening, then you can back to auto mesh and use that one. I'm just intentionally using both to show you which one works better. If the model is not very complicated, I don't have too many, I personally prefer selected area because I can see what's happening and it's under my control. If I want to edit anything, if I want to move any joint, I can do that. In auto mesh, I cannot do anything. And if you don't like it, you can simply come here and press none, so all auto mesh will go, and then you can subdivide the element. So here what we can do, we can use these and then apply. You see it just coming, but I don't see anything else. Okay, what else we need to do? You remember that all those elements are connected to the shells. They are right at the edge, they are good, but I prefer to have a better connection between those. So what I will do, I can select those elements in this level, and then I select them all here, and I can come here. I will close it for a while. I may select just few joints. As I said, I do prefer at least 3 segments that give me a better distribution. You can use edge constraint here as well. It's fine, but if the shell is just one go, the connectivity still is not very perfect. That's my personal opinion, guys. You can try different ways and see if they are suitable and you can use them. This software is improving, and the auto mesh features could be way better in future, so we don't have to do all of them like what happened in ETABS. So what I'm doing now, I'm selecting those joints and I'm coming here, and I use divide selected element at the edge, and here I'm just pressing apply, and then I can do the same for the other side and select those shells and press apply. So this is happening here. Now I'm going to the next level. In this level I do the same, but I use automatic mesh option for the same feature, just to show you that the result would be similar. So I'm selecting these. I can select them at the same time. As you saw, there is no angle, so you can select them together. And then I'm coming to assign area, automatic mesh, and I'm choosing the same option for based on points and elements on the edge. So I'm coming here, point object on the edge, and apply. So again, it just shows me this sign. There is no actual subdivision, so you can't see any extra joints here. And then let's move down. We have another level that we need to do this edit. So I'm selecting all of them. I'm selecting those joints, and likewise here. And again, I'm choosing this option and apply. So those are for shell elements by now, and then let's move up and see what else we have. So all of them are mesh. We can see the signs. Now we're reaching to here.